Hey everybody, we are Francesco and Tommaso and we are working on Sibyl. As you might already know, Sibyl is an hardware resource estimator for FPGA. As far as resource estimators are concerned, currently the result is delayed due to two long processes, synthesis and place and route. Sibyl aims to avoid synthesis to give developers a quick estimation, continuous feedback, so you can choose the best implementation and saving a lot of time. Today we are going to talk about the Sibyl implementation. The first implementation phase was the creation of our dataset, which we created to find out how the resource usage varied by varying the number of operations for each operation and for each type of data. So, with some scripts, we generated code like in figure, with chains of operation ranging from 2 to 1026. Then, we have executed the code with Vivado AGLS, and we have stored the results in a JSON file. The figure shows the result for the LUTs used by the sums of integers and highlights that in this case the trend can be approximated by a linear approximation. This other chart shows the result for flip-flop used by multiplication of integers. This time, however, the trend is far from linear. All of these results will be used later by the estimator, one of the two Sibyl macro blocks. Regarding the architecture of Sibyl, as I have just mentioned, there are two main blocks, the LLVM parser and the estimator. As for the parser, we used LLVM CPy, a binding Python of the C library of LLVM. What we do is get an intermediate representation generated with LLVM and extract the necessary information, such as the number of operations, dependencies, and so on. This gives us the advantage of allowing the developer to use a variety of programming languages. This is an example of how we extract data dependencies using the usedef chain. What the parser produces is this data frame, which contains all the information needed to calculate the use of resources. The estimator groups all the operations, avoiding counting the dependencies between data that match a resource reuse. And, using the dataset we mentioned earlier, we get the resources estimation. We have achieved good results regarding algorithms with low data dependency. However, for high data dependency algorithms, the results remain acceptable only for LUT. These show that there is still work to be done, especially focusing on making the intermediate representation more in line with the FPGA architecture. We also try to extract the patterns from the dataset instead of using the spline interpolation, and we will try to add the function of the intermediate representation that are not considered at this time. Thanks for the attention. If you are interested in Sibyl, feel free to contact us.